Problem number 1 states how many moles of oxygen will occupy a volume of 2.5 liters at 1.2 atms and 25 degrees Celsius. So we're going to use our ideal gas law for all of these problems. PV equals nRT. And also R in all of these problems is a universal gas constant, 0.0821 liter atmospheres per mole Kelvin. We want to start this problem the same way we've started our problems with all the other gas laws. We want to make a list of what we've been given. So if we just follow the equation, let's see. How many moles of oxygen? So that means we're looking for our N. Will occupy a volume of 2.5 liters. So we know our V is 2.5 L. At 1.2 atm, that's going to be our pressure. And 25 degrees Celsius. Now remember, we can't leave our temperature in degrees Celsius, so to convert that to Kelvin, we simply add 273, which will give us our temperature of 298 K. So from here, now it's very simple. We're just going to take our ideal gas law, PV equals nRT, and solve for our missing variable. Now, because this is such a very long equation, it's probably going to be the easiest for us, before we go and plug in all of the numbers, to just rearrange the equation now to get the variable we need. So if you remember, we're solving for N. So right now, N also has R and T attached to it by multiplication. So to get N by itself, we just need to divide both sides by the R and the T to get N by itself. And so our new equation becomes N equals PV over RT. And that's just going to help us make the equation a lot easier to solve. So P was 1.2 atmospheres. Our volume was 2.5 liters. R is our universal gas constant, which is 0.0821 liter atmospheres per mole Kelvin. And our temperature, 298 K. And now we just need to cancel out our units and solve the math. So if you notice, our ATMs cancel out, our liters cancel out, and our kelvins cancel out. And so we're left with our units of moles, which is good because that's what we're solving for. So if we punch into our calculator, 1.2 times 2.5 divided by 0.0821 times 298, you should get N is equal to 0.12 moles. And that is your final answer. Again, make sure you set up your equation, make a list of your variables, show your work, show your units cancel, and then put your answer on the line to get full credit.